All right, so the first type of transformation that we looked at were translations. We just moved it left to right and up and down. The next thing we're going to look at is reflections. Okay, and we can either reflect over the x-axis or reflect over the y-axis. And we'll also take a look and add a new family, which is the square root family. Okay, so we've done, the parabola, the quadratic family. So we're going to keep building on what we've learned so far. So a reflection over the x-axis would look something like this. So if we look at our points over here, well, just think, if I have an initial point right here, x, y, what changes if we reflect over the x-axis? Well, the x doesn't change at all, just the y. So if we look, the y just becomes the opposite sign. So if it's a positive y, it becomes a negative y. If it was a negative y, it becomes a positive y, right? It just basically, mirrors over that x-axis. It reflects over that x-axis. So if we think about a function, all we really do is negate our y. So if this is our original function, we just negate the y. So you might be saying, well, Mr. Etzel, you negated the f of x. Well, I really negated the y, but we just moved that negative sign to the other side. To move it, I could either multiply or divide by -1 on both sides. So if I multiply by -1, y would equal negative f of x. Because remember, f of x, our function is really the y. So one of the others negated. Okay, and we'll see that when we get to an example. I know that if it confuses you right now, that's okay. Well, the opposite is the case for reflection in the x-axis. So instead of negating the y, to reflect it over the y-axis, we're just going to negate the x. So if it was a positive x originally, we just make it a negative x. So if we look at it in our function form, here was our original y equals f of x, and now instead of having x, we just make the x the opposite sign. So if it was a negative in the first place, now it becomes positive, and vice versa. So let's look at an example so we can actually see how this works on a graph, and it might make sense of how we do this. So if this is my function, negative 2x minus 4. Remember, f of x I could just replace with y. Let's go ahead and graph that line first of all. So I'm going to grab my graphing calculator, so go ahead and bust that out. Go into your y equals, I got my negative 2x minus 4. And this looks like it's going to fit on the standard graph. So instead of just hitting graph right away, let's go to zoom, and that's zoom standard. Let's go from negative 10 to 10 and negative 10 to 10 on our x and y axis. So let's go down, or you could just hit 6, I guess. That's the quickest way. And zoom standard. So there's my graph. So if I want this to reflect over the x-axis, that would mean, so here's my x-axis. So like if I grabbed a point, let's say like, this point right here, it would reflect the same distance away on the x-axis over there. So I'm thinking this thing's going to look, something along the lines like that. Okay, well, let's actually do that on our calculator now. But before we do that, let's look at what we do to our equation. So coming back over here, remember we negate the y. So if y equals negative 2x minus 4, we want to negate the y. Well, when we graph it, we need a positive y. So to get it to be a positive y, I multiply by -1 on both sides, and I get y equals, well, it just switches all the signs, right? I get a positive 2x plus 4. And I could have done that right off the bat, right? If you don't want to put the negative with the y and have to move it over, just right off the bat, if y equals negative 2x minus 4, why not just multiply that -1 to both those terms? You're just switching all the signs to reflect it in the x-axis. So let's go look at that. So if I went to y equals, I could just straight up type in 2x plus 4. I could do that. And let's just go ahead and do that just to take a look. 2x plus 4 and graph. And it should reflect over the x-axis. Perfect, right? Imagine this is a mirror. It got reflected over the x-axis. Okay, there's another way to type this in so we don't actually have to calculate what that reflection is. So we're basically just negating this equation, right? We're negating this y, right? We're switching these guys around. So I want to go negate, right? Negative. And I want to put y1 in there. So it's just going to negate this equation. It's going to make it the opposite of this equation. To do that, we have to go into our variables selection here. So we go to vars, and then we have our y variables. This is where we can find it. So I got to scroll over and go into y vars, and we're just going to go into our functions. That's what we're dealing with, right? Functions. And we're negating y1. So I'm going to hit enter. So there we go. So basically, for my second equation, it's just going to take the opposite of whatever y1 was. Well, if y1 was this, it's going to take the opposite and graph 2x plus 4. So I can just do it in one step. Graph. There we go. I get the exact same thing, and I don't even have to type in the actual equation. And you could also type it in terms of what it is. So this is in terms of x, so I could use it almost as like a function. So y1 in terms of x. So there we go. It gives the same thing. So it's kind of like this guy right here. So for example, this was y1 when we graphed it, and then for y2, we basically took the opposite of y1 of x. Right? So that's how that worked. So what about the reflection in the y-axis? Well, instead of negating the y, we negate the x. So over here, we're just going to take the opposite for x. So it's going to be y equals -2, and this just becomes a negative x minus 4. Well, then how do I simplify this? -2 times negative x gives me a positive 2x, but I still have a y-intercept of -4. So let's go and graph this just to take a look. I'm going to get rid of this one. So let's just graph what we got. So 2x minus 4. And it should mirror over the y-axis now. Perfect. This is like your mirror reflected over. Well, what if I don't want to calculate what that is? Could I just negate the x? Yeah, so now we're not negating the y, so let's just put the y in. So remember variables, y vars, function, grab your y1. And then in terms of, well, instead of x, we want to negate the x. And there we go. So now it should just negate that x for us. So there's our original function, that -2x minus 4, and now it negated the x. So that's our 2x minus 4. Okay, so your calculator does some work for you, which is kind of nice. There we go. All right, so I'm going to go ahead and clear those guys. All right, so going back. So remember, to reflect over the x-axis, we want to negate the y. To reflect over the y-axis, we want to negate the x. Okay, and we just kind of showed that on that last thing, how that works. So if I want to reflect this equation over the x-axis, I negate the y. So really, I'm taking negative y, or y1, equals x minus 3 squared plus 2. And really all that happens is we negate the other side, right? Because I'd have to get this negative sign to the other side. So it's y equals negative x minus 3 squared, right? Because I'm distributing this -1. So -1 times this. So just put the negative sign out front. And -1 times 2, because we got to multiply by each term. So that would be -2 there. So that would be a reflection over the x-axis. And if you're not sure, you could check by graphing. So maybe I'll just do that, just to be safe. So our original was x minus 3 squared plus 2. Let's just take a look, make sure that looks good. It should be a parabola, right, because we got the squared here now on our x. So just shifted it right 3 and up 2, correct? Yep, right 3 up 2. There we go. And then, so two ways to do this one, right? So I could either type in this, which we'll do just to double check. So negative, and then x minus 3 in parentheses, squared, minus 2 now. So this is to reflect over the x-axis. We negated the y, or the whole equation. There we go. So here's my mirror, the x-axis. Perfect. So that worked out well. And remember, the other way to do that is to just negate y1. So I could go negative vars, y vars, enter, enter. There we go. So it should do the exact same thing. We're just doing this again just so we can really get this down so we can see it. There we go. Reflect over the x-axis. Okay, so just remember, reflect over the x-axis, negate the y. All right, and now the opposite is going to be true for negating the y-axis. We want to negate the x. So all we're going to do is just take the opposite sign for just the x. So it's going to be y1 equals negative x, right, because we're just negating, we're just doing the opposite sign, minus 3. It does not affect that minus 3. Squared, and then we still got plus 2. So that's the only thing that should change. Well, let's just go ahead and double check by graphing. So we got negative x minus 3 squared plus 2. So this should reflect over the y-axis. So this should be my mirror right here. Beautiful. Look at that. Just wonderful. And remember, if you want to do it the shortcut way, you could just go, remember now we're not negating the y, we're negating the x. So just go ahead and grab your y and the vars and the y vars. And then in parentheses, go ahead and negate your x, right? Because it's the function y1, this guy, and we're just negating the x. And that should just do it for us without us having to come up with the equation. There we go. Very nice. All right. So now we got some tricks with our reflections. Very nice. Okay. So let's go and take a look at our radical family now. So our radical family is y equals square root of x. And if I were to make a table of this guy and graph it, could I have a negative number? Could I do like -1? What's the square root of -1? Impossible, right? I can't take a number times itself and get -1, right? Because if I take a positive times a positive or a negative times a negative, I get a positive. So that's impossible. So I can't put a negative in there. The only time I could have a negative is if I had something else inside the radical. For example, like this. If I had x plus 2, well, then I could plug in a -2, right? Because I could take the square root of 0. But in this case, for our parent function of a radical, our parent graph, I have to start with 0. That's why there's a dot here, and it's not continuing on, right? There's no arrow right there because it doesn't go any further. So 0, 0, 1, 1, right? Well, what would be good numbers to pick for a table? Probably perfect squares. So like 4, which is 2 times 2, right? 9, which is 3 times 3, so 4 and 9. And then it's just the square root of those. So the square root of 4 is 2. The square root of 9 is 3. Okay, this is stuff that we should be good at by now. So there we got 1, 1, 4, 2. That's where these points come from, 9, 3. So there's our parent graph. Well, do our same rules apply that we've learned with translations and reflections? They should. So let's test it here. So let's just think. So I got the radical, the x is on the inside. So what would this tell me? Is that moving right or left? Yeah, that should be right 3. Remember from our rules. Remember because it's, x minus h tells you the move, and then plus k. And then so my plus k, this should tell us that it's going up 2. So remember, the x's is always the opposite. The y's, if it's on the same side, is just what it says. Remember, if it was over here, if this would have said y minus 2, and that would have been gone, then it's the opposite. So up 2, even though it's -2. So just be careful with how it's worded. We've already talked about all that stuff. So if I think about this, just grab a couple points and do it. So if I grab my original, write 3, up 2. So that would be my new start. And then grab the next one. 1, 1 would go right 3, up 2. And then my next one would go right 3, up 2. So it should look like that. But remember, it stops right there. And let's just double check. Let's go ahead and put that in our calculator just to make sure. So we'll put our parent function. So the square root sign is right down here. Remember, you got to hit second first to get the stuff in the blue. And then we put the square root of x. And let's graph that just to make sure it looks good. Very nice. Okay. You could even zoom in a little bit if you wanted to see it a little bit better. And then over here, so now we're going to do the same thing. So square roots. And our other one is x minus 3. So I'm going to put that in parentheses. I'm just going to write it just like I got it. X minus 3, parentheses. Now, don't just put plus 2. If you notice, I'm still inside the radical. You have to hit right to get outside the radical. It's kind of hard to see, but now I'm outside of it. Now I can put my plus 2. There we go. Now let's go ahead and graph that. So there we go. That shifted right 3 and up 2. Perfect. Good. So is this a function? Does it pass my vertical line test? Yeah. If I draw a vertical line anywhere, boom, 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 only crosses it once, so yes, this is a function. And your calculator actually only graphs functions, so if it graphs it, it's a function. What is its domain? Well, domain, remember, are your x values. So our x values start at 0, and then do they go on forever, or do they stop at some point in time? Yeah, they go on forever. So basically, all of our x values are greater than 0. And technically, they're greater than or equal to 0 because they could be 0 as well. So that's the domain. X values are all greater than or equal to 0 for my parent function. And the range, those are our y values, same thing. Starts at 0, they go on forever in the y direction, right? So the same exact thing. So y's are greater than or equal to 0 as well. So 0 or above work out. All right, let's look at just a couple more things here. So what do you predict the graph of these will look like now that we've done our reflections? Well, if I look at this left one, my parent graph is y equals the square root of x, correct? So let's just think about which one negates the y and which one negates the x. This one over here looks like it negated the y, right? Because if I had my original equation, if I negate the y, that's the same thing as negating the other side, right? Because you multiply both sides by -1. So y equals negative square root of x. So if you negate the y, this should reflect over the x-axis. So let's just draw this out. So here's my parent, 0, 0, 1, 1, 2, nope, 4, 2, right? So just like that. So if I reflect it over the x-axis, it should go -1, -1, 4, -2. It should look just like that. Okay. So what about on this right guy? Now it looks like we negated the x. So whenever you negate the x, that's a reflection over the y-axis. So this should look 0, 0. Instead of being 1, 1, it's now a -1, 1, right? Because it's reflecting over the y. This is my mirror right here. And then -4, 2, just like that. Very nice. If you notice, take a look at this left guy here. That looks like a parabola, doesn't it? Just sideways. So it's technically not a quadratic because it's going sideways, but how can I make these a sideways parabola? So let's think about this. If I had y equals the square root of x, that's this blue equation right here, right? To get the green one, what did I put in front of it? A negative sign, right there. So what do I have to put in front of this square root of x, you think, to get both these graphs? A plus and a minus, right? Because you need a positive square root of x and a negative square root of x to make that sideways parabola. Pretty fancy, huh? Well, what would I do with this guy up here? I have y equals the square root of -x, which made that. So how would I get the other one that would go down this way? Yeah, put a negative sign out front. So that's really plus or minus that. And I'd have a sideways parabola. Okay, so just some fancy things you can do with your radical functions.